Okay, so we are going to talk about how we can find a symmetric matrix that with every other diagonal matrix that we can construct, we will get the zero matrix. Namely, we want to look for a symmetric matrix, which is a non-zero symmetric matrix, such that it will be orthogonal to any other diagonal matrix, again for dimension n greater than 1. So what we're going to do is just simply doing the multiplication between the symmetric matrix that we want to construct and the diagonal matrix. We will do this inner product between them, and we will look for an inner product that will always give me 0, because this is the definition for what we are looking for orthogonality. So let's start. We are taking the symmetric matrix will be called S, and the diagonal matrix will called D. Now we need any diagonal matrix, so and we need just one symmetric matrix. So again, the inner product between two matrices, the forbidden inner product, the most classic one is, as you can see right over here, inner product between A and B is the trace of A transpose B. Now, because remember that we are talking about a symmetric matrix, so if we are looking on our matrices, the S symmetric and D diagonal, we are looking for it to be 0, but S is symmetric. So again, instead of writing S transpose, you can just write S. So we're looking for a transpose SD, because this is the inner product between them, to be equal 0. Now, if you are looking on a symmetric matrix times a diagonal matrix, you will notice that here it is, symmetric and diagonal matrix. You will notice that if you're looking on the diagonal, you will see that on the diagonal we just have A11, D11, A22, D22 for D's from the diagonal and A's from the symmetric. What does it mean? It means that on the diagonal, what you will have is just AII, DII, this multiplication. Why it helps us? Because when we are constructing, we want that if you're looking on the inner product, we are talking about a trace, and trace is just the diagonal values. So we want SII, DII to be 0. So what we need is that every element on the diagonal of the symmetric matrix to be 0, and that's all we need. So here we are, we constructed a symmetric matrix that with every other diagonal matrix, all the trace, the inner product, which will be the trace, will be 0, because we just chose the diagonal of the symmetric matrix to be 0, and this is it. This is the symmetric matrix that will be orthogonal with any other diagonal matrix, and that's it for now.